What's up, Algebra 2? Today we all talked about adding and subtracting rational expressions. So for anybody that wasn't in class, I'm going to preview everything we did. Feel free to pause it so you can look and see what we did, look through it. The first thing we talked about is common denominators. When you add together like terms, you don't need to do anything because the denominator is already the same. X minus 3 and x minus 3 are the same, so we can go ahead and add the tops together. Or subtract. Really be careful about subtraction because minus a minus makes a positive. So we talked about an example of how if you have unlike denominators with fractions, you need to go through what's called getting a common denominator. So with 10 and 3, we multiplied top and bottom by what they needed to make 30. And then once you add them together, you only add the numerators. You keep the denominator the same. So we talked about lowest common multiple and how you're looking to see what makes them all the same. So with this one, we multiplied by 3, got them all together until we got a final answer of a plus 6 over 3a squared. A can equal 0. Starting to think about factoring so that we can put stuff together, and then once we go through a pretty long process here, you end up getting this final answer over here. If you weren't in class, this may be pretty difficult to copy and understand, but you can copy it down and then you can come in and we can look at it later. We didn't do number 8 yet, but we did number 5, getting a common denominator after we factor out 3x, and then multiplying top and bottom by what each other needs. Kind of a longer process here because once you put that together, you need to multiply and combine all like terms. Similar here, we factored x plus 4 and x plus 4 to get the multiplies to be 16 adds to be 8. Over here, what multiplies to be negative 16 is 4 and negative 4, so they both kind of need one of each, 1x minus 4 on the right, 1x plus 4 on the left. We do some multiplication, and we combine like terms until we get this final answer here. We talked about some ACT style questions here. If this is calculated, what would the denominator of the resulting fraction be? So we went ahead and found that 12 is the number that you can use to get a common denominator for all of these, and that's why that one is B. And then I was really pleased that most people in the class understood this one. Multiplies to be 32, adds to be 12, has to be 8 and 4, and then these two x plus 4s can cancel out, leaving only x plus 8. So here we go. Here's the homework for tonight. Let's go ahead and talk about a few, and I'll leave some of them for you to do. These need a common denominator. You already have 2n plus 3 and 5n plus 3, so they kind of need each other. I'm going to multiply this one by 2n plus 3, top and bottom. And I'm going to multiply this other one by 5n plus 3, top and bottom. So when I'm looking at the top, 6n times 5n is 30n squared. 6n times 3 is 18n. Make that 2 a little easier to read. 2n times 2n is 4n squared, and then 2n times 3 is 6n. So now all of that is over this common denominator of 2n plus 3 and 5n plus 3, but I need to combine a few things that go together. 30n squared plus 4n squared is 34n squared. 18 plus 6 is 24n. And so now I'm kind of looking for that answer here, and that looks like it's D. So I want you to try number 2 to see if that's one that you can figure out from multiple choice. Go through the process, email me if you have any questions, and I'll be happy to cover that tomorrow in class. So let's try some that aren't multiple choice. This one is x minus 1 and x minus 2. No factoring necessary, but they do need each other, top and bottom, to have a common denominator. So now I've achieved a common denominator of x minus 1 and x minus 2. But now I have some distribution to kind of figure out. 5 times x, 5x. 5 times negative 1, negative 5. Now I'm going to group that, and I'm going to subtract, because that's what the sign in the middle is having us do, whatever I get for this one. 4 times x is 4x. 4 times negative 2 is negative 8. And like I was saying, subtraction can be difficult because a lot of times students forget to subtract each of the like terms. So let's look and see what we got. It looks like 5 minus 4 should be 1x. Negative 5 minus negative 8, which is really a plus 8, gives Excluded values, x cannot make the denominator 0, so if I had 1 minus 1, that would make 0. If I had 2 minus 2, that would make 0 as well. Okay? So these are my excluded values. X cannot equal 1 or 2. Alright, so like I normally say, I do 1 and then you do 1 on your own. So you try number 4 on your own, and then we'll try to check your work tomorrow. Number 5, I've got an n plus 4, and then I've got a 3. So this one definitely needs to multiply by 3 top and bottom. And this one needs n plus 4 top and bottom. And now I've got a common denominator of 3 times n plus 4. But let's go ahead and see what I would get in the top. 3 times 5 is 15. 6n times n is 6n squared. 6n times 4 is 24n. So I am adding between the two, so that's a little easier. And honestly, there's no like terms for the top to combine with, so I'm just going to put it in what we call standard form, 6n squared plus 24n plus 15. I have one excluded value, and I don't want n to equal negative 4. If I have in the bottom negative 4 plus 4, you're creating 0, and we cannot divide by 0. So you try number 6. We'll check your work tomorrow. Again, if you contact me, I will try to send you something that helps you with it. These are some review problems, so I think I'll try number 8, mix it up a little bit. You do number 7. Multiplication is a little easier because you're just trying to factor and cancel. That's what we did yesterday. So the first one looks like it has a GCF of 18. So when I divide 18 out of each one, I get n minus 1 in parentheses. Similar here, they both have 16, but actually they both have an n as well. And so when I factor out 16n, I get n minus 1. And so now we have some things that can cancel. N minus 1 cancels, n minus 1 cancels. And then I do have a small reduction here. I see 18 over 16. And so those kind of share some factors. And I also have this 9 here, so I may go ahead and start and say that 9 goes into 18 twice, and then 2 goes into 2 once, while 2 goes into 16 8 times. So let's kind of see what I've got left over. I have an n plus 3 in the top. I've got an 8n in the bottom. Put that more centered. And I think everything else cancels. So the denominator here better not equal 0 because of this 16n right there. 16 times 0 is 0, so that's a problem. And then I also had an n minus 1, so I do not want n to equal 1 either. Those would make the denominator equal to 0. So you try number 7, and we'll check your work tomorrow. Last one, when we talk about division, we take a moment to change the problem into something like multiplication. But when you change the problem from division to multiplication, these have to switch. That's called a reciprocal. X plus 5 comes up to the top, 1 goes into the bottom. And the only other thing left to do before we get started here is to think about what would multiply to be 5 but add to be 6. This is a factoring step. So I think about x plus 5 and x plus 1. 5 plus 1 is 6, 5 times 1 is 5. And I may stop and think about my restrictions for a minute. I do not want negative 5 to be an input. It makes this one equal 0. I don't want negative 1 because that would make that equal to 0. And negative 5 as well right here, I don't want that to be divided by 0. However, I already have negative 5 as a number that we excluded. So now I'm going to go ahead and look for things that cancel. I have x plus 5 that cancels with x plus 5, and really my final answer here is x minus 8 over x plus 1. So you try number 10, and we will look at that tomorrow. Thank you so much for watching the video. Have a good night.